Good day to all of you. In this video, we're going to answer the questions. Are there such thing as negative numbers? Specifically, we're going to look into the following objectives. The first one is make sense of negative numbers and their application in real life. Represent positive and negative numbers on a number line. At the end of this video, there going to be a task which is based on the stuff that we'll be discussing in this video. So I expect you to listen very well. The summit of Mount Everest is about 8,850 meters above sea level, and the surface of the Dead Sea is about 430 meters below sea level. Represent their altitudes using the positive and the negative numbers. So guys, in these examples, you have the summit of the Mount Everest is 8,850 meters above sea level. Okay, above sea level. The phrase itself, above sea level, it means that it's actually plus 8,850. So this one we can actually symbolize as positive 8,850. Okay, now phrases that says 430 meters below sea level, 430 meters below sea level. Okay, that's below. So meaning to say if that is the sea level, below that one, all right, is 430 meters. While this one is above that one, is 8,850. That's above the sea level. This one can actually be written as negative 430. Okay, so that's the meaning of the expression above sea level and below sea level. Now, okay, so guys, let's try to look at a bit the history of numbers so we will be able to appreciate the integers. Before, guys, when you start to count, for example, you started with 1, 2, 3, 4, 5, 6, blah, blah, blah. These are what we call as counting numbers. And then after that one, you have learned the concept of zero. Okay, so when you add zero there, so for example, 0, 1, 2, 3, 4, 5, and so forth and so on, this set now of numbers is called whole numbers. Take a look. Without zero, they are called counting numbers. With zero, they are called positive numbers, or sorry, whole numbers. Now, but the counting numbers has a special name. The 0, 1, 2, 3, 4, 5, 6, okay? It is actually a special name, which is actually positive integers. So they are called positive integers. They're actually called integers, okay? And then, for example, you've learned, for example, before that, let's say you have your friend owe you $5. Okay, when you owe someone, that means actually minus $5 or negative 5 because you don't have that money. You owe that money, so that is actually negative 5. If, for example, you go to the bank and you actually take $100. You take $100 or you withdraw $100. So the withdrawal of $100 is actually negative 100. Okay? Now, or if you deposit, otherwise, if you deposit, for example, 50, then that one is positive 50. Okay? So these are the set of negative Those are negative numbers. Now, these zero, positive numbers, and negative numbers can actually be represented in the number line. What is this number line? If you're going to draw, for example, a horizontal line, on the middle of that one, you can find zero. Zero is the origin of the number line. As you go to the right, they must be equal distances from each other. Okay, as you go to the right, this is going to be your positive 1, positive 2, positive 3, positive 4, positive 5. And then as you go to the left, you have negative 1, negative 2, negative 3, negative 4, negative 5, and so forth and so on. So please take note that to the right are positive, to the left are negative. And all of these guys, all of that number is called integers. Okay, they're called integers. So these are the positive integers, these are the negative integers, and the middle one is 0. Now, what is important here is that every point is unique. Every point is unique. What do you mean by that? Every point is unique. For example, that is 2. Is there another point here on the real number line that represented by 2? No, there is none. The 2 is only exclusive for that point. Every point is unique from each other. This is negative 2. It is impossible for 2 points to have different numbers. Okay, so every point is unique. Another characteristic of this is that when you go to the right, the numbers are increasing. Okay, when you go to the left, the numbers are decreasing, right? But hold on. Let me just get another paper here, for example. So what am I trying to say is that you can use this one to compare numbers. So for example, which one is greater, 1 or 5? As you can see, the 5 is to the right of 1, right? So therefore, this is actually less than, 1 is less than 5, because 5 is to the right and 1 is on the left. Whichever is on the left, that is the smallest number. Now let's try to compare. You have negative 3 and 2. Oh, be careful. You need to look at which one is on the left. That is negative 3, that is 2. So the negative 3 is on the left. So therefore, that one is less than. Now let's say, for example, negative 5 and let's say 5. Which one is on the left? So therefore, this one is less than because it is on the left. Now, so let's say now I have 0 and negative 2. You need to again check which one is on the left. So the 0 is here, the 0 is there, the negative 2 is here. So the negative 2 is on the left. So therefore, 0 is actually greater than negative 2. Having said that one, can you try to pause the video and let's say you have 0 and negative 100. Which one is into the far left? Basically, this is the one on the left. So 0 is greater than negative 100. Okay, so that's the one that I would like you to know about this, that we can actually compare numbers, compare integers using this. Okay, now you actually need to visualize that. Let's try to have one more example. So let's say now that you have negative 3 and you have negative 1. Which one is greater? Is it the negative 3 or is it the 1? So as you can see, this is less than this. Why? Because this is to the left of negative 1. Whichever is on the left of a number, that is actually the smaller one. Okay? Now, another thing that we're going to look at here is that for every point, there is actually a corresponding inverse. It's not in your book, but I will just insert that one. There is actually corresponding inverse. So for example, the 2, for example, this is point A. This is the inverse of that A. All right? So the inverse of the A is -2. They're inverse with each other, right? So -2, therefore, is the inverse of 2. Okay? It is actually specifically what we call as additive inverse, because there is another term which is multiplicative inverse, but this one I'm just referring to additive inverse. So for example, 4. What's the inverse of 4? -4. What about -3? The inverse of -3 is 3. Why is that so? Because similar to -2 and 0, they're actually have the same distance from the origin. So that's why they're inverse from each other, because they're the same distances from the origin. Now, having said that one, what is the inverse of -100? So definitely the inverse is actually equal to 100. So in this case, guys, what we have learned, the negative numbers are the one on the left of 0. The positive numbers are the one to the right of 0. These numbers are -1, -2, -3, -4 are integers. So they are negative integers. These are now the positive integers. Now, Mr. Daniel, what about if we let's zoom it. Let's zoom. Okay, I'm gonna draw another one, and that is 0, and that is -1, and that is 2. Okay, as you can see, there are actually numbers in between. And what is this one? That is actually your 1/2. And this is your 1/4. Sorry, that's on the left. So that's -1/4, -1/2. Correct? So there are actually numbers in here, small numbers. This one is -0.75. Okay, it could be a fraction, it could be a decimal. So there are numbers between 0 and -1. In the same manner, there are also numbers between -1 and -2. There are small numbers in between there. Okay, so let's say, for example, this one now. Okay, before that one, sorry, this should be 1. Why did I put 2 there? So, for example, this one now is your 0.5. It's just the same with 1/2. This is now 3/4. Okay, it's just the same as 0.75. So what am I trying to say, guys, is that there are numbers also in between these numbers. Okay, now, so let's check. So let's say now you have -1/2. Which one is greater? -1/2 or 0.5? Definitely this one is smaller. Okay, now let's say, for example, you have 3 numbers. You have -2.5, you have 3, then you have 1 and 1/2. And I would like you to arrange this one. You locate that one into the real number line. Okay, so first you need to look at the 0. Then let's say that is now -1, -2, -3. Okay, then this is 1, 2, and 3. And now let's locate the 3. The 3 is this one. The 1 and 1/2 is here on in between. And then the -2.5 is actually here. Now, how would you arrange this one in ascending order? You can sometimes in the question, you will be asked to arrange the numbers in ascending order. So in ascending order, that's going to be -3, 1 and 1/2, and 3. Okay, now the opposite of ascending order is descending order, which is actually from the bigger number to the smallest number. Okay, that is one of these skills that you actually need to know. Now let's try to have some examples here. Okay, this is the conclusion, all right, based on what we have discussed. Now, all right, so in this will represent the number line. We have drawn that one, the number line. Okay, you can actually do that one. Arrange the given numbers in ascending order. So therefore, that's actually -3, 0, and 2.3. All right, I think just for the sake of discussion, I'm gonna show it. If that is 2, that is 1. 2.3 is somewhere here. So that's 2.3. And -3 is somewhere here. So that is now -2, and the -3, that's 0, and that's 2.3. All right, that's the answer to this one. Now let's try to look at some problem solving. Represent the numbers in the number line. I think I'm gonna skip this one. Okay, this one you can actually do by yourself. Can you write numbers greater than -8 and less than -17? Okay, can you write a number greater than -8 and less than -17? Is that possible? Greater than -8 and less than -17. Let's try to, just for you to be able to see, that is your -8 and that is your -17. The question is, can you write a number greater than -8 and less than -17? The answer is, there is none. Why? Because it's impossible for a number to have greater than -8 and less than -17. Now let's try to look at these examples here. The table shows the average monthly nighttime temperatures in the Gobi Desert for some months. Arrange the month in ascending order of the average monthly nighttime temperature in the Gobi Desert. So in this one, you're just being asked to arrange the month. So this in descending order. So you're going to start actually in the biggest one. So in that case, that's actually July, after which is May. July, May, and then you have -9 November. So -9, and then -10 in March. And then you have December. Yep, you have December. And then you're gonna have January, -January. All right, that's the answer. So guys, I would like you now to go to the task. So you need to answer the task 2.1. There are actually 5 questions in this task. Okay, please answer them in not A4 but your paper line, and then submit in Google Classroom. That's all for today. Have a good day and goodbye.